some homogeneous equations. But again, they're already given in reduced row echelon form. So our work is minimal. Let's leave it that way. All right, so below the main diagonal, we only have zeros, and the pivot values are the only values within each column that are non-zero. All right, so x1, I'll write the equations first, and then we'll kick it over into parametric form. So minus 7x4 plus 2x5 equals 0. x2 plus x3 equals 0. x4, thank you. x3 plus 5x4 minus 4x5 equals 0. Alright, so we're looking at x1 equals 7x4 minus 2x5. x2 is equal to negative x4. x3 is equal to negative 5x4 plus 4x5. x4 is a free variable, and so is x5. Everything else is dependent on those. Which means that this is a dependent system. I'll just make a note of that. System. All right. So, if you ever have any free variables, it's indicating that it's going to be a system, because in most cases, well, not always, I suppose, but in most cases, it means that other variables are dependent on those free variables. Right, so that's what's happening here. x1, 2, and 3 are dependent on whatever x4, x5 are. All right, so to put it in parametric form, let's say x1, 2, 3, 4, thing. No loose constants, so everything is either a coefficient of x4 or x5. So I'll start with the x4, obviously, I think. So 7 is a coefficient of x4, negative 1 is a coefficient of x4, negative 5, 1, and the last entry doesn't have an x4 in it, so it must have been a coefficient of 0. Plus x5 has a coefficient of negative 2. x2 doesn't have an x5 in it, so it must be a coefficient of 0. Then a 4. Coefficient of 0 for x4, and a coefficient of 1. And so that's our parametric form. Again, a dependent linear system. Whatever x4, x5 are, will dictate what x1, 2, 3 are. Okay. So instead of actually writing all of your equations just to move things around, you could just kind of cut to the chase. So let me just address that. Here's x1, 2, 3, 4, 5, 6, 7. All right, so this is definitely a dependent system because we're looking at entries in the X4, X5, it just basically entries everywhere. All right, so we can isolate what those are. X1 seems to be a free variable. Okay, I don't see a pivot value in the X1 column. So you could actually just, I mean, if you want to sort of, I don't know, split the difference a little bit, maybe you don't want to go all the way to the final answer without doing any intermediate work. You want to show a little bit of something along the way. You could still come up with, I guess, the blue column without coming up with the black stuff here. All right, so maybe we'll just do it that way. X1 is free. X2, well, it would be X2 minus 5x4 plus 5x7, but those are getting moved to the other side, so it becomes, so you're basically reversing the signs. 5x4 minus 5x5. X7, yeah. I said it so confidently, though. All right, X3. We have a negative 7x4 plus 3x7. X4 doesn't have a pivot, so it's free variable. X5, well, that's just flat out equal to 0. All right, it's completely reduced form, no other coefficients there, so equal to 0. It's kind of a nice development. X6 would be the same as X7, and X7 doesn't have a pivot, so it's also a free variable. So it looks like everything is dependent on, oh, I was going to say, dependent on X4 or X7, but I get that X1 there. Well, that stinks. All right, so unfortunately what that means is that we have an X1 with 1 followed by a whole lot of zeros. Plus X4 let's see, we have a 0, 5, negative 7, 1, 0, 0, 0. So 0, 5, negative 7, 1, 0, yeah. Plus X7. No X7 in the X1 equation, a negative 5 in the X2 equation, a 3 in the X3 equation, nothing in the X4 equation, nothing in the X5 equation, then 1, 1. All right, so that seems to be our parametric form. I just want to verify one little tiny thing. I always verify the constants. Just making sure that following that level of the, I guess, simplification or the expansion, however you want to think of it, would in fact give me that constant. So x1 times 0 plus x4 times 0 plus x7 times 0 would in fact give you a 0. So I'm feeling pretty good about that. So if there were other constants in there, I'd use that as kind of a little checking mechanism. It's not foolproof, but it'll get the job done.
Example 5, do you need to do the same thing with x6 that you did with x1?
Did I miss x6? Ah, crikey. There's 6 columns. Thank you. I guess I'm not done with that video. x6 equals x6, right? Okay, so then so all zeros except for the last one, which would be a 1. Thanks.
What's the significance of including the 0 columns in parametric form? Is there any?
The 0 columns?
Like x1 and example 6. Why do you include that as a free variable and it's just...
Oh, because it's not represented with a pivot value. So because it doesn't have an actual numerical value or a dependent expression related to it, it must be free. So we account for that just by stating that it's a free variable. But in terms of actually having the 1 column, that's just the way it worked out for this matrix. Because the assumption is that the matrix came from somewhere, some collection of data, and so that's just how it bore itself out. Let's see here. Yeah, because we don't have elementary column operations, but if we did, it would make sense to make column 2 equal, swap column 1 with column 2. But yeah, it does feel weird that there's an entire column of zeros, but it's just a 0 vector. So part of this matrix or part of this system has the 0 vector, the equivalent of the I vector in, what is this, 5 space, and so on. So these are just vectors that emerge. But for whatever reason, the order seems to be important to whoever crafted this problem in whatever textbook.